Hello, so I want to spend a minute or two talking about how to safely work with these boards. They're not going to hurt you, but we don't want to hurt them, okay? It's possible to damage them unintentionally with the simplest of things. They all have their sort of kryptonite, and that would be with just metal, like the end of this resistor here. If it's plugged in, powered up, and I drop this resistor onto the board, or I inadvertently set the board on top of something metal, or even on top of this, this resistor here, which is set slightly off to the side, it's possible that I could have that wire jump across any one of these solder joints and potentially cause it to short and arc out. That can destroy the processor or some of the small sensitive components on the board. Okay, all of these things are very sensitive to direct metallic contact. And when you're working with building creations, you got to make sure you isolate your electronics from, for example, metal chassis of robots. That can be very detrimental. I've certainly seen students screw a board or a sensor or something along that line directly to a metal chassis, causing the wiring below to arc across, and of course it can destroy the sensitive electronic devices. The other thing is just the physical handling of these devices that can easily cause damage. These Unos are pretty robust. They use the classic old USB connector, which is pretty strong and well soldered to the board. It's unlikely in normal use you're going to break this off. But this Teensy, for example, which has a USB micro, or this Nano, which has a USB mini, these can be rather easily damaged just by, if I plug this in. This cable that I'm going to plug in right now is not powered. It's just going to be demonstrative. If I plug this in, all right, now if I apply pressure on this, an upward pressure, that's quite a lever, all right? And it is not uncommon to rip this right off the chip. And of course that destroys it. We can't put it back on. So you want to be careful with the physical handling of these small USB ports. It's very easy, not terribly so, but you do have to be careful. You don't want to rip it right off. Again, that leverage is working quite a bit in your favor. If you just simply set the board down and against something like this and press on the board, that's going to cause a force and potentially rip that right out of the chip. The other thing to consider is while uploading. So if you have a code and you go ahead and compile it, the first thing it's going to do, of course, is compile, and you'll see that action happening here. It's compiling, and then it's going to go to this upload. If I had pulled this out while uploading, that can damage memory sectors within this processor or on the Teensy or any of these, and potentially cause it some long-term damage. That's basically it. You have to avoid water. You don't want to, in the winter time in particular, you got to watch out for static. I try not to work with these things on plastic tables. They tend to generate a large static charge, and I have certainly burned out a couple of processors with the static charge. You'll notice my desk here is actually, I'm sitting on a piece of paper, but it's a wood desk, so it works out really well. I don't have to worry too much about static charge. And I tend to ground myself. So as I'm working, and before I actually touch the electronics, I will touch something metal and make sure that I ground myself. Not too much of an issue in the summertime when the humidity is so high. Okay, well, hopefully that was useful, and I will see you all again soon.